streaming and start informing people what's going on.
Just cities. There's almost.
Right. I guess people will join. Let me call the help desk.
Well, does she agree? Yeah, this year. Yeah, we're gonna do shrooms. Yeah, we're gonna decriminalize mushrooms, and then they tried to decriminalize like everything. Yeah, like across the board. I don't know if that passed. I don't know about that. I mean, I don't care for people.
Hi Jessica, this is Nick Egovich over in biology. I have put in a request to update computers in Cavness 031. It's our computer lab over here. And I'm starting class, and we're getting a fatal error on our R studio. No one can get it started.
Yeah, it was like 5 days.
And when I start R, I can see that there's some missing packages, and I went ahead and rebooted the computer, just wondering if we needed a reboot to get the new image through, but
Yeah.
no, still, I'm getting fatal error. Yep. I put in a work order on Monday to update R and R Studio, because those are the programs that we're using, and they moved to the new versions earlier this semester.
Yeah, getting out there in Montana, in Alaska, just make me want to go to state people more.
Yes.
Yeah.
Yep.
Everybody there is like, people, do that, like, let me do that one. That's my mentality.
Yeah, so that they can see it. I mean, I don't know how much more I can do in class, because it's kind of, I've merged lecture and lab, where we use the program during the lecture.
Obviously, that's. How you feeling about the test?
Not so bad. I
don't know how many it's gonna be on the species.
Yeah.
Cause it's like relatively heavy on that, like the only other thing is the turnover.
Yeah, but I think we're good on species. Like basically in here, so.
Yeah, and I don't know if he's.
Okay, thank you.
Probably say that.
All right.
Yeah, you probably would. So.
All right, so we've got.
I still need to look at, I need a picture of that page that has all the species.
Oh, yeah.
All right, so we've got fatal errors on our R, unfortunately.
So what?
So they're putting in the ticket. They're gonna try to get field technician over here. I don't know. Surely someone. I mean, if they're gonna push it through, surely somebody would have come over here and tested it. Obviously, they didn't. So that was the error, and then the other one. So we also have the R. So I thought I can just go ahead and load up R, and we can go through it. But you can see that methods, utils, graphical devices, graphic stats methods, none of that is found, which means that it wasn't successfully installed. The libraries weren't ever transferred over. There's really no. I mean, I think that's part of what the R code execution, the fatal error messages. Now we should be. I don't know if I would be able to update my packages. So you can see it now. There's graphics. So I can just do. I wonder update that packages and see if that works. Yeah, I wonder let's see here, update packages. I don't know what the actual command line is. See, the question mark is, like, it gets the help file. Yeah. See, some things were not updated properly.
Interesting.
It's, I'm gonna do a search here. I do have an idea. Let me check something. So you know how we have the R folder that has the Win library on it? I think this is 4.0, I believe. All right, let's see here. We got to take it. Someone just texted or just emailed me. Let's see what they say. Our software upgrade. No, so he just said that the follow-up, so the 3 machines weren't updated. So 15, 17, and 19.
I'm on 16.
15, 17, and 19. So I guess I'm going to, he obviously did not get the ticket. So none of yours open, right?
Fatal error. Dying. Errors. What was the last one you played? It was 7 or 8. Oh my god. It's been a long time. Okay, yeah. Good graphics. Yeah. This is the same format, right? Yeah, yeah, for sure. Thank you so much. So, yeah.
All right, send that. So maybe he didn't get the message. Okay, there it is. Oh yeah, cool. All right. So that's what Maddie just posted, the code, the functions. Because I kind of think update packages should have worked just with really without any options. Just, but again, update packages isn't being found. So if it's not found, then we're missing stuff, and I think that's in the utils package. So it's just not, it hasn't been updated properly. So we'll see what happens. In the meantime,
If it had that function, it would like auto suggest. Right?
yeah, it looks up, it compares what's installed and what's not installed, or what's installed and compare it to what is on the repository, like what version numbers. So what I'm going to do is check out
You also have like
Yeah, I guess I can. Well, yeah, we'll let the whole trucking here. Can't really get the size.
I mean, the libraries show that they're there. But it is not. It's not starting properly. Oh, here it is. What does yours say? Your fatal error message? So it tells me right here that it's looking in the wrong spot. It should be looking in your own spot, your username, for all the packages, and it's not. It wasn't. This wasn't installed properly. This wasn't updated properly.
Is there something we can do, or do they have to go in?
Once a technician gets here, I'll show it to them and say that this should have been done under an administrator account. That you can't do it under a user space. And they're gonna, I'm sure they're gonna say, well, it was. It wasn't. But it is. So what we're gonna do is just, we're gonna continue this. So let me open up. Go ahead and open up my presentations. You can follow along, can't do it. But we are on the post-hoc tests. So we don't lose out on some of this stuff. There it is. So we don't lose out. What we'll do is we'll just kind of plug ahead. I'm going to say thanks, Maddie, for the updates. Yep, it's in the utils package. It's not found. R's not starting it. So what we'll do is we'll just kind of plug ahead. So, so as we said, we ran our ANOVA. We had a significant p-value, right? Which means that our means, at least one mean is different from the rest. We don't know which ones. And that's our goal. Once we know that at least one mean is different, we want to try to figure out which means are different. So we've got, what we're going to run is a post-hoc test, or a series of post-hoc tests that are aimed at figuring out which of the means are different. And we've got two main tests that we're going to run. All right, so we're going to run a Tukey's honestly significant difference test. All right, this has a built-in function called Tukey HSD. All right, and we have to run it on an ANOVA table. All right, that's in the base package. This is great when we want to do all pairwise comparisons. So if we had Lake A, Lake B, Lake C, and we have a difference and we want to figure out which combinations are different, Tukey's HSD test will work. But if we have an experiment where we have treatments and we're comparing the treatments to a control, we don't want a pairwise difference, because a lot of times we don't care if the individual treatments are different. We only care if the treatments are different than the control, because a lot of times what we're looking at is, does the treatment have an effect on our measurement variable? So we don't want to run a Tukey's HSD. We want to run something called a Dunnett's test. Dunnett's test compares each of our treatments to the control, and only these treatments to the control. You don't compare treatment 1 versus treatment 2 and so forth. All right, so why do we do this? What's the basis for these post-hoc tests, and why we run these two different types of tests? Well, it comes down to our alpha levels. What is an alpha level? What is an alpha? What does alpha mean? Type 1 error, right? So what is a type 1 error for the analysis of variance that we just ran? 0.05, right? We set it at 0.05. So we run that test. We have a 5% chance of committing a type 1 error. All right. What Tukey's and Dunnett's tests are doing are basically a series of t-tests. Equivalent. They're equivalent to a series of t-tests. Right? All right. So if we're running a series of t-tests, so we just just said for the analysis of variance, the ANOVA was 0.05. We ran a t-test before, right? What was the alpha for our two sample t-test? When we ran a two sample t-test, what was the alpha level? 0.05. So when we run the test, we have 0.05. Now let's say we have 3 groups, A, B, and C. We know a difference exists. We ran an ANOVA, right? All right, so then what we're going to do is run pairwise tests. What's the alpha for each of these tests? So these are 2 groups now, so we're now going to run a 2 sample t-test. What's the alpha for each of these tests? What's the alpha for the collection of our tests? Not 0.05. So each of our tests had a 0.05. But in our post-hoc test, we have to run each of these. So what's the chance that we actually commit a type 1 error in one of these tests, or in the collection of tests? Each one is 0.05. So we can have this one have a type 1 error and these do not. This one could be a type 1 error and these do not. This one could be a type 1 error and these do not. Maybe these two have a type 1 error, maybe these two have a type 1 error, or these two have a type 1 error, or perhaps all of them made a type 1 error. So you can see that as we did additional tests on the same data set, we no longer keep our alpha level at 0.05. Our alpha is going to start increasing with each test that we run. Now, we don't worry so much about going from an ANOVA to this part because we already know a difference exists. But what we do have to worry about are all of these as we try to figure out which means are different. And this is where our post-hoc tests come into play. Our Tukey's, HSD, and our Dunnett's test control for inflated type 1 errors when we do these multiple comparisons. All right? That's why we use them. That's why we can't run just a series of t-tests. Every t-test that we run has a 0.05 alpha level, but each subsequent test that we run on the same data set means that our overall type 1 error rate is going to keep going up and up and up and up and up. All right? So, how does this actually run? How do we run? Fortunately for us, we created our model, right? Our linear model. So if we were looking at doing all of the pairwise comparisons, IT?
Yes.
All right, cool, awesome. I left our error message up. And it's been basically on everyone's. Let's cancel. Let me see if I moved it. I have an idea of what happened. So right now, just on the R console, these packages aren't found and they're required. R doesn't run. And I think that is partly why I get the fatal error message. And that's our fatal error message. And I think what it's doing is whoever updated it, it's looking at their personal folder for the libraries instead of what's on the computer. Yep. And it's happening on all of theirs.
Alright, okay. We're getting in contact with the guy that set all this stuff up.
Okay. So yeah, that's I just wanted to show you what's up there. Yeah, he just emailed, and I emailed him back and told him that it's not working. intro. All right, so we made our linear model. That's why we did it. All right, we did it so we can use this, do the ANOVA table easily, and so we can run our posthoc test. So what we're going to actually have to do is use Tukey HSD, but it's not on the model, it's on AOV. So AOV is ANOVA, but the AOV function gives us the information that's used to create the ANOVA table. It's going to give us the sum of squares, it's going to give us our degrees of freedoms, and so forth. All right, so to run a Tukey's, this is what we would run, and what you see is that we get 3 different comparisons. We're getting a treatment 1 versus a control, treatment 2 versus control, and then treatment 2 versus treatment 1. And it gives us our p-values. So with our p-values, that's we look at. And this test is doing the same as our regular test. Our assumption is whatever groups we're comparing, we're testing if those means are equal. We don't care the direction. We just want to know, are they equal or not? So here, we get this situation where one of them, the treatments, treatment 1 versus treatment 2, are the only ones that are different. So if we were going to use this, if this was, let's say, this isn't, I know we have a control here, and it's not the test, this isn't the test we want to use, but if we were using a Tukey's, this is how we would write it up. You did your results of your ANOVA, and then you report your Tukey's posthoc test, and you report what was different. Now with our Tukey's, we don't have a test statistic. It's giving us the difference in our means, all right? The only thing that we're gonna really need to report is our p-value in that case. All right? And we'll do that.
Why was had treatment 2 or yeah? Why is treatment 2? Oh no. Now I get it. We have control and 2 treatments. Okay.
And it goes alphabetical order.
Okay.
So the difference is treatment 1, the mean of treatment 1 minus the control gives us the negative number. Treatment 2 minus the control gives us the positive. Treatment 2 minus treatment 1 gives us the positive.
So
And these are the mean. These are the difference in mean. So from the aggregate function, we can actually see that that's what those differences are.
so the looking at the p-values, the 2 treatments are different from each other.
Yep.
But neither one of them is different from the controls.
Yep. But that's probably not our interest. Our interest is in if these treatments have an effect. So our concern isn't the treatment 1 versus treatment 2, but it's all relative to the control. So that gets us back to this. We did 3 tests. As we add that 3rd test, we're increasing the chance that we create a type 1 error, which means, in essence, the critical value that we use as our cutoff for between that rejection and acceptance region gets smaller. So we become a little bit more conservative because we did 3 comparisons instead of just 2. So that's, Tukey's is great, but you have to know that if you have a situation where we're not interested in doing this, we're going to be too conservative with our p-values. In other words, these p-values that are being reported here are going to be higher than what they should be because they were adjusted. That's why they said p-adjusted. P-ADJ, adjusted p-values. Adjusted to get us back to alpha 0.05 for the collection of tests. Each of them might only be, let's say, 0.01, but the collection of tests then gives us an overall alpha level of 0.05. All right. I'm going to introduce this. So there's a package called the MultComp package, multiple comparisons package. All right, it has several different multiple comparison procedures that we can use. The one that we're going to use is Dunn's that's in there. All right, it has Tukey's, and we'll show you how Tukey's gives us the same thing, but we need it for Dunn's, all right, for that comparison versus the control. So what we would do is load up our MultComp package, and then the function that we use is GLHT. general linear hypothesis test. And we're going to run it on the model. And the test that we're running is a linear function. So the linear function kind of sets up what comparisons we're going to use. Now, it's built in. We have a bunch of MCPs, multiple comparison procedures, that are all built in that tells R what the linear function actually is. So the ones that we're going to be interested in are the tests, either Tukey or Dunning. All right. So as we create it, you're going to see that the only things we change in this line is going to be the group and the test, where the group is the grouping variable that we're using, and this test is that post hoc test. So just for an example for Tukey's, this is how we would do it. We have our model. So I think I called it mod 1 in my R. All right. We're going to run GLHT, general linear hypothesis test, on that model, where our linear function is a multiple comparison procedure where the group, because that was a variable name that was in our data set, equals Tukey. And Tukey's is in quotes. And I save that as a GLHT fit, and it's useful because then when it's done, we can take the summary of the GLHT fit and we get the same table as Tukey HSD. Is there a reason to run this one over the Tukey HSD? No, there's really no reason. I mean, there is. And the reason why I introduce it is because sometimes we only want to compare certain groups, and this gives us that ability to do that. But in terms of Tukey HSD, the regular Tukey HSD versus this, Tukey HSD will. So you'll notice we get the exact same p-values as the Tukey HSD function. Just two different ways to do it. And then if we wanted Dunnett's, all that we have to do is change group equal Tukey to group equal Dunnett. All right. So I think what we're going to do, since we don't have R, I'm going to let you try this at home. Run Tukey's, run Dunnett's on our mod, and then what we'll do is we'll check, make sure it works on Friday, make sure you're getting this output, and then ANOVA, you can work on this fish length. So you can do the fish length at home, have this worked up on Friday. If you're stumbling on the post hoc test, don't worry, we'll kind of cover it, but have this fish length text kind of go through everything that we should have. You know, figure, like a write-up, and even if it's just the write-up through the ANOVA, let's go ahead and do that Friday, give you practice. We'll review it. All right? So we're out a little early today. Gives Cody time to practice his intro lecture today. All right.